Hello.
Sir,
Hello. 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 Iraf.
yeah,
Okay.
hi sir. Good evening, sir. Sir, I have some question from week 4. Can I ask, sir? Just small question.
Wait a minute. Wait.
Okay, sir.
What is the agenda of today's session?
Uh, Today's agenda will solve some questions. I think they're from uh, week 1 to 4, right? I don't know.
Yes, sir. Week 1 to 4 is the syllabus for our
Hmm.
quiz 1 also.
Okay. So this is not exactly the practice for quiz 1. Okay. We
Sir,
just yeah.
on calendar it's mentioned it's a solve with us session of week 4.
Yeah. So
So can I ask, sir?
yeah. Okay. Ask.
Yeah. Sir, in week 4, we have at the end of the lecture, we have something related to this R square, which measure the goodness of it. But in the video, ma'am doesn't give any specific formula how to find our R square. So is there any formula or is it out of syllabus uh,
No. No.
to find R square? Yes, sir. That's the first question, sir.
Mm.
How to find R square?
Let me share my screen.
And sir, I want to know. Okay.
Mm-hmm. Okay.
Okay, sir. This is the first one. Yeah.
Is my screen visible?
Yes, sir. Yes, sir.
Okay. So what can you see
So I'm saying there is one question in a university of. Yeah.
now?
So now blank page. Yeah.
Okay. So yeah, what was the question? R square. So you know what is R, right?
Yeah, I know, sir. R. That's a Pearson coefficient, correlation coefficient. We can say
So what is R square now?
square of R.
That's it.
No, sir. I'm asking about capital R square. Capital R
So
square.
that is R square. Okay. That small and capital, that is same. Okay.
Okay, sir. But when the ma'am use the Excel sheet and when she's finding the value, the R value and different.
Can you repeat that? Your voice got.
Yeah, sorry, sir. I'm saying, sir. So simply we can say capital R square is simply small R square, right, sir?
Yeah, yeah. Simply, you can do this, right? And I mean, the things that you are being taught on Excel, that will not be ours, right? There are some different things. You would just have to consider this, that okay, what is R? R is Pearson correlation coefficient, which lies between -1 to
1
+1. Do you know
plus 1.
this?
Yeah, I know, sir. I know that's a
Yeah.
range. Yeah,
Okay.
usually
Yeah. So what it tells us, if the value is towards the negative end or towards the negative side, we say that there is a negative correlation between them. Okay.
correlation. Yes, sir.
What is negative correlation?
When one value is increase and simultaneously the other value decrease, other variable
Exactly.
decrease. Yeah,
Exactly. So yeah.
negative slope.
Now what is R square? R square will simply bring all the values to the positive side. Okay. So R square will
But
actually not tell you, yeah,
yeah, sorry, sir. Go ahead. Sorry.
R square will not tell you about the uh, whether it is a positive or a negative correlation. Okay. It will only tell you the strength of correlation.
Okay,
Okay.
okay, sir. But in the video, ma'am said that R square is tell you the measure of goodness of fit of line. That's what I'm
Yeah.
asking.
Yeah. Yeah. So that is strength of correlation is similar to goodness of line fitness. Okay. Sorry. Goodness of fit. Okay.
Yeah.
So that means let me show you. Hmm. Yep. So consider these are your data points, right?
Okay, sir.
Now you draw two lines. One is this, and one is this. Okay.
Which one is best?
Which
Describe
one is
according to
better?
this point. Yes,
Yeah.
sir.
So is it
The,
A or is it B?
Up, so this data is actually so spread, but we can go with A. Yeah.
Yeah. You can go with A. Now if you calculate R square for A, so suppose you calculate R square for A, okay,
Yeah.
and you calculate R square for B, okay.
Yes.
you will find that R square for A will be greater than R square for
Yeah.
B.
Mhm.
Are you getting this?
Okay, sir.
So R square
Yeah,
will
I
give
know.
you some idea about what line is
Goodness of it.
goodness of
Which
it.
line is
Okay.
good fit? Yes, sir.
Hmm.
Sir, but my
So,
question is, like when in the question, in the exam or in the quiz, when question comes how to find R square. So if we simply do the square
yeah,
of small r, that is
yeah,
a
you
correlation coefficient.
find out the correlation coefficient and you square it. That's it.
Square them. Okay. Okay, sir. Got it. Sir, next question. I have, sir, a small five, two, three question more.
Okay,
Like, what is
fine.
the range of, sir, RPV, that is point by serial correlation coefficient, that is used for association between numerical and categorical variable? So in that, is there is a range, just like we have a range for small r, for range of RPV, point by serial
So,
correlation coefficient.
I don't know. Let's check it out. Let me see.
Okay.
Have you gone through the lectures?
Yes, sir. I gone from all the lectures, sir. But
Hmm.
maybe I don't know. But I didn't find this range. I find the range of capital R square also. I find the range of small r also,
Uh,
and I didn't search in the internet.
yeah. Even I didn't search in the internet. Let me check
Okay.
it now.
I think it will not come, sir. I think
Okay.
it will not come, maybe.
Yeah.
But I'm
I
just
don't.
asking, sir, is it in the syllabus or not?
Uh,
Range of RPV. Yeah.
no. Okay. So it is not in the lectures, but let's just search it now. Uh, what do we have to check?
The range of
Range of
point by serial
point by serial.
correlation
Uh,
coefficient.
okay. Correlation. Okay, let's check it. Okay, it is from -1 to 1. Don't know if the
Okay,
correlation
okay,
is
sir.
closer to 1. It's okay. So, I mean, the interpretation is same, right?
So, sir,
It is,
minus one
if
to
it is,
one, we can say.
yeah, if it is towards the -1, we say that it is strongly negatively correlated. Okay.
Correlated, yes, sir. Got it. Sir,
And
with this same, sir, can you go to the lecture slide? You just open it. Uh,
mm,
yeah. Sir, here, sir, can you scroll up? The formula is not visible for me. Sir, there is a message comes like this meeting is being live stream. So, can you
okay,
remove
what?
this message?
Okay, let me see. Let me see.
Okay, sir, it gone for me.
No,
Yeah,
no.
sir, can you go to formula? Sorry. Yeah, can you go to formula,
What
sir?
formula? Want to see the
Yeah, sir.
form? Yeah.
Why not, sir? Why not minus y1? Sir, how does it decide if we do y naught minus y1 or we do y1 minus y naught? Like there is
Okay,
a
you
one
can.
question. If
Mhm,
y naught, like y naught is less and y1 is more, so then it should be negative.
mhm.
So we can go with this same formula or we can do y1 minus y naught also. That's I'm asking, sir.
You can go with the same formula, I guess, right? Because let me check.
And yeah, and
Mhm,
along with this same concept, sir, like the uh, ma'am said that you have to take like male or female as decoded to 0 and 1. So which one we know? Ki male should be 0 or it is 1, or female should be 0 or female should be 1. How to decide this,
mhm.
sir? Or we can randomly decide according to our will.
You can randomly decide. You can randomly decide. There is no tough fixed rule. You can
Oh,
since
okay.
both of them are what was it? What was it, ordinal or was it nominal? Male and female.
No, sir. Male and female are not ordinal. They are just nominal category.
Nominal, right? So you
Yeah.
can't give 0 or 1, right? I mean, there is not a fixed way that you can give 0 and 1. Okay.
Yeah, yes, sir. So, sir, actually, what I understand from this point where this decoding of 0 and 1, we can randomly assign 0 and 1. And usually,
Mhm,
how I decide, like, y0 is more. So, the one which is more, like, let's say female is more,
mhm,
then I decide
mhm.
it's 0 and then 1. So that y0 minus y1 will be a positive number. That's
Yeah.
how I do,
Mhm.
sir, usually.
Okay.
So,
Okay.
is it
That's
correct, sir?
correct. It is correct. It
Oh,
is correct. You are doing correct.
okay, sir. Thank you, sir. Sir, one more, sir.
Mm-hmm.
Just last two, three questions.
Yeah.
Two question
Yeah.
more.
Ask it.
How to
Yep.
find R by U?
Hmm?
Yeah, sir, there is a question. We have equation of line. From equation of line, linear equation of line. So
Mm-hmm.
from linear equation of line, ma'am discussed ki we can find R. We can find R correlation coefficient. So how to find that, sir? By seeing a equation of line.
By
Do you get,
seeing
sir,
an
what I'm
equation
saying?
of line. Yeah, I
Yes,
am
yes.
getting it, but yeah. Okay.
Sir, there is a one question I can show you. It's
Okay.
maybe in
Where is it?
the practice
Is it
assignment,
in?
or yeah, practice assignment. I think so. Same, 14. It's already visit grade assignment. Sorry, it's not practice assignment.
So, please.
So it's visible on the dashboard, sir. Here. Question number 14, right side. Yeah, this one.
Okay,
This one is
this.
this one is the question.
This grade assignment. Okay, has the deadline passed yet?
Yeah. No, sir. It's not passed. But sir, can
Oh,
you
please.
take any example related to this random equation?
What random equation, bro? You'll get the solution then.
So obviously not, sir. How you can decide? You can, sir, explain the concept by taking a general equation y equals to ax plus b. So I didn't
No, no.
understand that topic.
Okay, what question
Yeah.
are you asking? 14, this one, right?
Yeah, the similar topic ma'am explained. And let's say we have equation slope intercept form y equals to
Okay,
ax plus b. Then the value
okay,
of a decide how to
what
find
question
r.
are you talking about? What question are you talking about?
14, sir, 14.
14, this one.
Yeah, it
14
is
is
similar to
not
the
slope
question which I
intercept,
asked.
it's covariance. You have to estimate what will be the
It is
covariance
not that
between.
partial. No. It's a equation of line. If you see that Bharat is actually y, and it is exactly 100 rupees more than the twice of Anjali. So Anjali, let's say
Yeah,
x,
so
so
your
2x
data
plus
set
100.
changes now. Your data set will change for each value since there are 6 recordings. So you have to
Okay,
use
guys.
the that
Yeah.
formula.
Okay, please don't discuss grade assignment.
Okay, sir. Let's
Okay,
don't discuss this
yeah,
grade assignment. Sir, can you go to
yeah.
whiteboard, sir? Sir, please. Sir, can you go to
Whiteboard,
whiteboard? Yeah,
this
sir.
whiteboard, this is
Yeah. So
blackboard.
can
Okay,
yeah. Oh, sorry, sir. Sir,
okay.
can you write
Go
the
ahead, go
equation,
ahead.
sir?
What equation?
So can you write the equation y equals to ax plus b or mx plus b, whatever it is. So now ma'am said that by using this equation of line, you can predict or find the value of r. So I'm asking
Hmm.
how to find the r, or how we can say it is strongly correlated or linearly correlated, or is there
Okay,
is a way to
okay.
exactly find the value of r?
Uh,
Yeah.
Iraf. I would encourage you to go and just like how I search this, you can search about this. Okay.
Okay, sir.
I would
Thank you.
like to do it. Yeah. And if there is a doubt, you can ask, you join the TA sessions and all.
Okay. So one last question more. I said two, sir.
Okay.
So V4 tutorial. Can you open V4 tutorial, sir? V4 tutorial, sir.
Before tutorial, what
Yes,
you
sir.
do.
Sir, here in the question, uh, sir calculated the RPV. So four, tutorial number 4. Yeah, sir, can you go to at the end, sir? Teach at the end. Yes, sir. 11 minutes is fine. Oh, so after, sir, there is a teacher calculate RPV. Can you go? You can go, sir, at the end to get to the answer. Yeah. So here, sir, sir calculated RPV. That is 0.75 by the process which we already know. And
Mm.
here the question is, which gender can be said to be earning more? You can read the question, sir, if you want. So my question is, how sir decide ki it's female? Why it is not male? We have to tell in the question, we have to tell ki which gender can be said to earn more. Means we have to tell ki is it male or female. So we get the value of R as 0.75. Now how to decide whether it's male or female?
Okay, you'll not decide it. You will not get it from this R.
No,
You'll
sir.
need something else. You'll need something else. Let me see. Uh, which gender can be?
It's based on the mean,
Yeah,
the
it's
value
based
of
on
the
the mean,
mean.
right?
No, sir said in the video, sir said we have to calculate the mean first. Obviously, we have calculated the mean, that is on the right side, F and M,
Mhm.
that is 57.9 and 31.55. And then sir said it is not enough. We have to do the RPV. Then after finding RPV 0.75, he just said, okay, female is fine.
Okay,
Now
female also.
yeah,
You'll do
how he's
this.
deciding?
Okay,
The
you
answer is
can't just
female,
take
yes.
the. Yeah, you will need to consider the proportion also, right? You will need to consider the
Proportional.
proportion also. So, I mean, if the number of females and number of males, I mean, is it if it is different? So, yes, the professor said right that just calculating the mean will not be enough. Okay,
Hmm.
so you need to consider the proportion also. So what you do is you multiply it by proportion or do something, okay, and you'll get an idea. Okay.
Sir, I do proportional, and in
Mm.
by doing both, I know that female is more. But
Mm.
what is why he is calculating, sir, point by serial coefficient?
I think that
And
is related
then
to
after
previous questions, right?
no, sir, it's the same question. It's a single question only, sir. 30 minutes is only this one question. I'm sure.
Mm.
Yes, sir. Then he after finding these two, he said that it is not enough. We have to calculate the R. So if we are clearly knowing in the starting ki female mean and female proportional is more. So why we are calculating R? What is the like how he is getting ki after finding R he is deciding it's female? That's I'm not getting.
No, you're calculating R so that there is a relation between the two data to confirm
Cal
that the relation is valid because it is 0.75. Then you
yes,
can
sir.
say that the mean is, I mean, the values are valid. That is why it's calculating R.
Sir, I know.
Because if R was
Yes, yeah.
point,
Sorry.
let's say if it was 0.1, right? That means
Hmm.
your data is not correlated. So then you cannot give an answer for this value. Since it is
No.
0.75, it's correlated.
What is the use of point biserial coefficient?
Yes, sir, I understand. Point biserial
Confirm the
correlation
relation between the
coefficient.
two data.
How the categorical variable that is gender is related with the monthly income that he is deciding. That is the point of point biserial correlation coefficient.
Hmm.
Here we got
It's not
0.75.
how,
It
it
means
is to
that
Not how.
confirm proof. It
Yeah,
is to
yeah.
we
confirm
need a
proof.
confirm proof, just like Parth said, that we need a confirm proof whether the monthly income is somehow related to the gender. Okay.
We get sir 0.75. It means that it is strongly, we can say
Relate.
not very
So
strongly. Yeah,
yeah,
it is
let's
related.
suppose
But yeah,
if it
but my
was
question.
0.1,
So it means it is not related.
it is
These
not
gender
related.
and monthly.
So
Yeah, I got it.
which gender can
Yeah.
be said to, I mean, see, which gender can be said to be earning more, that can be answered from uh, this average and proportion also. Okay. Mean and proportion also it can be answered. Right. Point biserial correlation coefficient is an extra calculation that we have done to find out, okay, whether they are correlated or not. Okay.
Sir, one last clarification. I got it, sir, all the things. I know what is this RPB and why it is used. My question
Mm.
is, ki, okay, it's fine, understand. But how the teacher is deciding ki it is male or female? If you are saying, sir, ki, okay, it will be decided by the mean and it will be decided by the proportion, then there is no need, in my opinion. Let's say we find, sir, RPB and RPB,
There
let's
is,
say, come 0.1, as fast, sir, said. So how we decide? If RPB, let's say, become 0.1, then how we decide?
Mhm.
It is which gender is can be said to earning more.
Then
Should
you
we go
cannot
with
give
the
an
same?
answer. No, no, then you'll not have
Okay,
an answer.
okay.
That is what it means. So if your
Right, sir?
R
Mm.
is closer to zero, that means that the data that you're using to calculate the mean is not
Hmm.
related. Hence, your answer will not be valid, either of them,
Mm.
because the
Okay,
data is
okay, sir.
not
I got it.
related.
So, sir, in short, we can say if the RPB is very less, although we know that the
Mhm.
mean of the female is greater, but RPB is very
Mhm.
less. As far as sir said, ki it is
Yep.
0.1. So it means that
Mm.
ki we cannot decide which gender should be earning more.
Okay.
Right?
Yeah. Right.
Right, sir?
Exactly. Exactly. That's like Parth said. Okay.
Okay,
Sir,
okay, okay. I got it, sir.
I want to know
Acha,
one
sir.
thing. Today's class is
So
about
actually,
PY.
honestly, last question left. But sorry for asking more question.
Okay. So let me
So,
rename this session to solve with us. Instead of solve with us, we can write as solve with Iraf. Okay.
No, no,
Last
no,
question.
sorry,
Last
sorry.
question, Iraf.
So,
What is it?
honestly, sir, last question just for tomorrow.
Mhm.
Sir, there is sample variance and population variance, sample
Mhm.
covariance, population covariance. We have used,
Mhm.
and in the denominator we use n minus one.
Mhm.
So I'm
Mhm.
asking. Sometime I see some question. It is just asking find the variance or find the
Okay.
standard deviation.
Okay.
So
Some of
how
the
to decide
questions
whether
are,
you have
yeah,
to use
some of the
sample or
questions
whether
are,
yeah.
yeah, some of the questions are, I mean, confusing, but in the quiz, okay, it will be clearly mentioned whether it is population or sample. Okay.
Okay, sir. If in case, sir, it's not mentioned, the this tutorial teacher it go with the sir sample. So I'm asking,
Mm.
should I also go with the sample? Yeah.
Yeah.
Oh, sample
Yeah.
variance. Yeah.
Okay. If the
Okay,
tutorial ones
okay.
are, you have watched the tutorials one.
Yes, yes, sir. I watch it all for yes, sir.
So if they're going with I mean, the sample, you can go with the sample. Okay. But yeah, in
Until
most
and unless it
probably,
is not
yeah,
mentioned.
yeah, in most of the cases, it will be mentioned. Not most of the cases, almost all the cases, it will be mentioned whether it is sample or population. Okay.
Okay, okay. Thank you so much, sir.
so
My doubt is clear. Thank you so much, really.
okay, dear. So, I want to ask, sir, what is the agenda for today? Like, we are doing PYQ,
Not exactly PYQs, but questions related to some random questions from week 1 to 5. Sorry, 4.
random questions.
Yeah.
Have we discussed week 3 GAs?
No, I don't think we have discussed week 3 Gs. Okay, so are you able to see the screen at the PPT?
Yes, sir.
Yes, sir.
So association between two categorical variables, and okay, this is your first question.
Is the answer 33.33 something?
Yes, sir.
Yeah, 33.3.
Okay, sir. There is no need to discuss this question.
You want to discuss? Okay.
No,
What
so
about the
basic.
total students are sophomore? Okay. So yeah, anyone needs to discuss this, just speak up right now, or I'll skip it. No one. So yeah, the answer is 0.33. Then what's the second one? How did you all find week 4? Was it easy as compared to last 3 weeks, or I mean, all the weeks are easy?
Sir, we were exactly wanting to GAs are the one that is week 3 are to be discussed at least
Hmm.
after this.
Yeah, I think there will be a session, or in the TA session, you can ask me, right?
Is the answer 40.66 around?
40.66.
Yes.
No, no. Let me get one more answer, then I'll check.
Forty point 66.
40.66. So let's see. No, it's not 40.6. What did you all do? what proportion of total students do not own a credit card? So how
It
will you
should
do
be
this?
58 plus 45 plus 19 divided by 300.
Okay,
Maybe
so
we
50.
are calculating the percentage. So in that,
Okay, what do you say? 40.
We have answer is correct, but it's, I think
Yeah.
random out.
No, no.
I think
So proportion, when you are asked proportion, you tell the ratio. Okay.
in which case we have to say the percentage.
When percentage is mentioned.
Okay.
Okay. Or the options are in percentage, but when ratio or the proportion word is used, you'll usually tell the the ratio, right? Like this 0.4.
Okay, sir.
Yes, sir.
Third one.
Zero 0.14.
Yes, sir.
No,
0.14.
it's 42.
32,
42 by 300.
Yeah.
32 by
No,
300. No, no.
42 by 100.
Tell the exact ratio, na?
Sir,
42%.
0.14.
0.14. Let's say 0.2. So what proportion of students who own a credit card are freshmen? So first tell me how many people own a credit card.
Okay, okay, sir. Got it.
The people who
So,
own a credit card are 42 plus 55 plus 81, right?
plus 81.
42, uh, 55 and 81. So the number of students owning credit card is 42, 55, 81, that is 178. Out of these 178, how many are freshmen? So how many are freshmen? 42, right? So 42 upon 178, that is 0.24. Anyone who didn't got it?
Yeah, I was wrong. I just calculated
Hmm.
42 and plus freshman out of, I think.
Hmm. So, okay, so
So,
in
wording is
contingency,
important.
yeah, in contingency table, be aware. I mean, now you all will be aware that these kinds of questions will come. Okay. In which is it out of total or is it out of something? I mean, in this case, you had to take out row relative frequency. Have you know about row relative frequency, right?
Got it, sir.
Right. So, okay, fourth one.
Sir, what is row relative frequency exactly means?
Hmm. What row relative frequency?
Answer is yes, I think, but what exactly it means?
Just a second. How do I remove this? Okay, so wait just a second, guys. Let me.
Yes, sir. I think.
Okay, so let's move into yeah. So um, okay, have you all solved this?
Yes, sir.
Have you all solved this question?
Yes, sir. I
Yes,
think
sir.
answer is yes, but I don't know what it is.
Okay, you don't know what it is. How do you get the row relative frequency? Fine.
Screen is not visible.
Screen is not visible right now. Yeah, I think I'm having some network issue. Yeah, yes, please. Just a second. I'll rejoin. I'm not able to share my screen. I'll rejoin the session. Just a second. Mm. Yes, guys, I'm here. Just give me a second. I'm not able to share my screen. Yeah, am I audible right now? Wait, who was asking about row relative frequency? Just a minute, Steve. Just a Okay, meanwhile, if you guys have any you want to do a verbal conversation, we can do it. No one? No one interested in a talk? Mhm. Yep, guys, it must be invisible now.
Yes, sir.
Okay. So let's solve this. Yeah. So what were you guys asking? You calculated row relative frequency. How do you calculate the row relative frequency? First, you calculate the total. Okay. How do you calculate the total? 42, 55, 81. What is it?
So,
Hmm?
hello, sir.
Hello.
Can I
That
just join the class? Can you tell me which week is this?
Think this is week.
7 is the total.
Yep. Sorry.
78 is total of first row.
How do you calculate 42, 55, and 81? Add them up. What do you get?
178.
Yes.
178,
And second is 122.
122. So you got the row total, right? How do you get the row relative frequency? You divide 42 by 178. That is the row total. 55 by 178 and 81 by 178. Okay.
Okay, and the below also
Below you'll divide by 58. What is its row total? Its row total is 122.
120.
So divided by 122, 45 by 122, and 19 by 122. Okay.
Got it, sir. And if it was a column relative frequency, then columns are total, right?
Yeah, you have to calculate the column totals. For example, for this, you calculate the column total 42 and 58, that is thing 100, right?
Yes,
You
sir.
divide 42 by 100 and 58 by 100. Okay.
Next is also 100.
What? Yeah, next
Next
is
one
also
is
100. Yeah. Okay. So I think
third.
for column related, everyone will be divided by 100, right?
Yes, I got it.
Each of the number. Okay. So now is the row relative frequency similar for all rows? Have you all calculated?
No, it is not similar to all rows.
No, it is not similar.
Okay. So you calculate the frequencies here and you calculate the frequencies here and you check like this. Okay. Are these similar? Okay. Then okay, let's see what's the next question. This is done. This is done. No, not done. Not done. 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 Okay. No, is there a relative frequency? Then no. So therefore, so as you can see, these are the frequencies, right? 0.42, 0.4555, right?
Yes, sir. All are different.
So all are different. So 0.42, 0.4858, 55, 545. So these are different. So let's go ahead now. Consider the following survey questions. Then, is there an association between the year of study and owning a credit card? So how do you answer this from the previous, taking help of this previous information? How do you answer this?
No,
There is no year of study.
No.
no.
Okay, have you all not watched the lectures? Or have I not watched the lectures? Now I can't even differentiate. Okay, so you calculate the row relative frequency, okay, and then you compare them. If they are similar, then what happens? If the row relative frequencies are similar, are the two variables associated? Someone answer us. Able to see the screen?
Yes, sir.
So if the row relative frequencies or the column relative frequencies are similar for all the rows, then we say that the two variables are not associated with each other. Okay. And if they are different, then we say that the two variables are associated with each other. Got it?
So these are related to each other, no?
Yeah. So if these are different, right, the ratios were different. So if they are different, then we say that the two variables are associated with each other. So what's the idea? What's the idea behind this? What are we trying to find out? We're trying to find out that whether the two variables are somehow associated. You know what does associated means? Associated means that having some idea about one variable gives you some idea about another variable. Are you getting this? What does associated mean? If you have
Yes, sir.
if you have some idea about one variable, you can guess something about the other variable. That is actually association. So if the ratios are same, right? For example, if the ratios were 0.2, 0.2, 0.5, 0.5, 0.7, 0.7, right? For just like for this table, right? For yes, no, for freshman, sophomore, and senior. Okay. So now what can we conclude from this?
These
You
are
can
all
see,
not to each other.
yeah. So here you can see the ratios are same, right? the ratios are same. So we can say that it doesn't matter if you are a freshman or a sophomore or a senior. It doesn't matter. The ratio for a freshman also is 0.2 and 0.2. I mean, 0.2, the freshmen are not able to, I mean, the freshmen 0.2 have a phone and 0.2 does not have a phone. Okay. For
Yes, sir.
sophomore, 0.5 have a phone and 0.5 does not have a phone. I mean, it doesn't matter that you are a freshman or a sophomore or a senior. The ratios for owning or not owning a phone is same, right? And you can look
Credit
at,
card.
yeah, you can look at from the column side also, right? So it doesn't matter whether you own a phone or you don't own a phone. The
Sir,
ratios
but the
for
question
Mhm.
year, na, they were
What?
saying, are you related to years? Question is
Yes.
about the year. Yes.
What years? Let me see. Where is years? Is a row relative frequency similar for all rows? We answered this, right? It is not similar. Then the next is column relative frequency similar for all columns? We skip this or what? Yeah, we skip this.
Yes. Yeah, we skipped that and we
Okay.
goes to the question. Years are
Okay, so
there.
I mean, I told you, right, how to calculate column related frequency.
Yes, yes.
Okay. So now, is there an association between the years of study and owning a credit card, right? So credit card, uh, we saw that the row relative frequency are
Oh,
different, right? So if they are different, that means the two variables are associated. Okay. Since the row relative frequency are not same for all columns, we can say that two variables are associated with each other.
Sir,
Are you
it is
getting
not
this?
necessary that the row relative columns are same for all, right?
Okay, can you repeat that?
Sir, I was
What?
saying that it is not always necessary that the row relative columns will be same for all the rows and similar for the column related frequency also, right?
Okay, you can go either with the row relative frequency or the column relative frequency. Both will give you the same answer, right? It will not make a difference.
Yes, sir, but I was asking that it is not necessary that they will be same.
No, it will, yeah. I mean, it's a very low probability that they will be same.
Okay, sir.
Hmm.
सर जो ईयर वाला क्वेश्चन था उसमें वो क्या कहना चाह रहा है मतलब आंसर क्या है और
Where is year question? I can't see. That's a this what between the year of study. Year of study is this freshman, sophomore, or senior. You you are in freshman year, or are you in sophomore year, or are you in senior year? Okay. So you got the question or you read the question or what?
क्वेश्चन इज रेड बट ये ईयर ऑफ स्टडी जो टॉपिक है मतलब ये
Year of study is
एसोसिएटेड
this. Year of study is this. What year are you in? Are you a freshman, or are you a sophomore, or are you a senior?
तो आंसर तो इज नो है ना
Yes, answer is no. Okay. So freshman, sophomore, or senior. Okay. So what happened? What is the data here? Ki these are freshmen. We are the freshmen, and among the freshmen, 42 said, okay, we own a credit card, and 58 said that we don't own a credit card. Okay. Then we asked the sophomores, in which 55 said that we own a credit card, and 45 said that we don't own a credit card. Then we asked the seniors, in which 81 said that they own a credit card and 19 said that they don't own a credit card. Okay. So is there a relation between the year of study and whether or not they own a credit card? You're getting this?
यस सर गॉट इट
Hmm. So you can see that the ratios that we calculated are different, right? Okay, we got it here. So now you calculated these ratios 0.42. So if you're a freshman, see, this is a freshman, right? You calculated the probability or the percentage, the ratio that, okay, if you're a freshman, there is a 0.42 chance that you own a credit card and 0.58 chance that you don't own a credit card. Are you getting this?
Yes.
Hmm. So, I mean, if you're a freshman, we have some idea that, okay, what is the higher
So
probability?
I
Hmm.
have a query.
Hmm.
So isn't it the chances of have owning a credit card is continuously increasing as we increase the year? Like freshmen have lower
Hmm.
chances of owning a credit card as compared to the senior. So is not it increasing?
Yeah, it's
This is
increasing.
not
It is increasing, but that is not I mean, that's not the way that you check. Okay, it is increasing. But now what you have to understand is if you are a freshman, if you're a freshman, there is a 0.42 chance that you own a credit card. Let me change the color. Yeah. So 0.42 chance that you own a credit card and 0.58 chance that you don't own a credit card. Okay. If you're a sophomore, there is a
Yes.
0.5. Yeah. Okay. Nothing. So if you're a sophomore, 0.55 chances that you own a credit card and 0.45 is the chance that you don't own a credit card. Okay. And if you're a senior, there is a 0.81 chance that you own a credit card and there is a 0.19 chance that you don't own a credit card. Okay. So you can see the difference in the probabilities, right?
Right.
Yeah. If someone says, okay, I am a senior, what? If someone says, I'm a senior, what would you predict? What would you predict? Whether he owns a credit card or he doesn't own a credit card? What will you say? You have to give one answer.
But yeah,
own a credit.
81% chance that they own a credit card and 19% chance they don't own a credit card.
Yeah. So if a person comes and says, okay, I'm a senior, can you predict what you will predict that, okay, if he's a senior, there is a higher chance or a higher probability that he owns a credit card, right?
Sir, the question
Yeah,
I
right.
think seniors
Mhm.
are if seniors categories like same. Okay. Then what can we say about these are relative frequencies? Are not same or not same?
Can you repeat that? The question?
If seniors are frequencies are same, then how
Hmm.
can we say about columns like related to
Yeah.
or
So
not
that,
related here?
yeah. See this. There is a difference, right? 0.81 and 0.19. Okay. So now if a person comes and says, I'm a senior, you will predict that, okay, he has a higher chance that he has a credit card, right? But if the
Explaining, sir.
probabilities were, yeah, if the
Sir, I
probability
said if we change, sir, if we change this, yeah, if we change
0.5
same,
to 0.5. Now, if these were the ratios, right? That means if you are a senior, there is a 0.5 chance that you own a credit card and 0.5 chance that you don't own a credit card. Now, if a senior walks in, will you be able to tell whether he owns a credit card or not?
no.
No, right? So that is why when the ratios are same, we say that the variables are not associated. Okay. Association comes
It's
into the picture when these ratios are different. You're getting this?
yes, sir.
Okay. So for this case also, you can see that if the person says I'm a freshman, what will you predict? Whether he owns a credit card or doesn't own a credit card?
Chances are for no,
Chances
not
for
owning
no,
a
right?
credit.
So, okay, what is association? Key having idea about one variable gives you idea about another variable. So what was the idea? The idea was I'm a freshman. This is the idea, right? Now you are able to predict that he has a credit card or not, right? So
Sir,
if you can predict this, then we can say that, okay, the year year of study and whether ownership of a credit card is associated. Getting this?
Yes, get that.
Yeah. So finally, I mean, the final crux is if the ratios are different, you will be able to give a prediction and you can say that the variables are associated. But if the ratios are same, you will not be able to give a prediction and you say that the variables are not associated. Okay. Any doubt? Can you go ahead now? Okay. There are two factories A and B which produces a square-shaped wooden sheet of varying length. What is the population standard deviation of measure of site? Video is paused. Okay, I'm not doing anything right now. Okay, are you guys solving this? Hello.
Yes, 30 seconds more.
Okay, okay.
I don't know, sir, but I got 5.11 something. I don't know it's right or wrong.
Okay. So should I go ahead now? Or is anyone still doing? Speak up. No one. So I'll go ahead now. What is the population standard deviation of measure of sites, right? So measure of site is this 23523. Let's see. So how do you get the standard deviation? Xi minus x bar whole square divided by n. Since it's population,
I got
you will divide it.
1.897 something.
Okay. So 23523. These are the measures of site, right? What you do is you calculate the mean first. What is the mean for 23523? The mean is 3. Okay. Once you get the mean, you calculate this xi minus x bar, that is 2 minus 3, 3 minus 3, 5 minus 3, 2 minus 3, and 3 minus 3. Then you square this. You square this and you get 1, 4, 1, and that's it, right? Now, what is standard deviation? First, you calculate the variance. The variance is this xi minus x bar whole square divided by n. So you sum up all these values, you get 6. So numerator is 6, and 6 divided by n, that is 1, 2, 3, 4, 5. 6 by 5, and then you take the root. So got it, everyone? Anyone having any doubt?
No, sir, go ahead.
Okay.
Sir, wait a second.
Yeah.
Here, when we just squared it out, then what operation we did?
Where? From xi, from this to this?
After this squaring, yeah.
Yeah. See, what you have to do is you have to calculate the sum of the squares. Sum of the squares. You're seeing this? Are you getting this formula? Sum of all the square differences.
That is 6, na?
Hmm. So that will come out. No, that will come out to be 6. The sum will come out to be 6. See this. You got xi minus x bar, right? Xi minus x bar. This.
Sir, can you solve this question?
Solve this question.
Till square is, I think, is clear, na? So everybody, I think.
Yeah. So what you do is you have to calculate the standard deviation of this, right? Measures of side. You calculate the mean. How do you calculate the mean? 2, 3, 5.
The mean is 3, sir.
Okay, the mean is 3. Okay, so let me just write mean is x bar is 3, right? So once the mean is 3, what is the formula for standard deviation? Standard deviation is under root summation of xi minus x bar. What is xi minus x bar? Xi minus x bar is xi is all the data points, right? All the data points. And what is xi minus x bar? Xi minus x bar, what does it give you? It gives you the distance of data point from the mean. Are you getting this? Xi minus x bar gives you the distance of data point from the mean. Okay. Now this distance can be positive or it can be negative. So what we do, we square this distance so that it is always positive and it gets added up. Okay. And you divide it by, since it's population, we divide it by n. Okay. You got it or not?
We got it.
Yeah. So you calculated the mean, right? The mean was 3. Now you calculate the deviation from the mean. So deviation from mean, it is 2 minus 3, that is minus 1, 3 minus 3, 0, 5 minus 3, 2, 2 minus 3, minus 1, 3 minus 3, 0. Okay. So these are the differences, but we don't know that we don't need the differences. We need the square difference, right? Because right now, if we add this up, add these up, you see these will get subtracted. This will come out to be 0. So you calculate the square. So minus 1 square is 1, 0 square is 0, 2 square is 4, 1 square is 1, 0 square is again 0. The sum comes out to be, what is, this is the sum that we are calculating. The
6 by
squares we
5.
have done, yeah, the squares we have calculated. Now we are summing these up. You get 6, right? And 6 divided by, and n is 5, right? And you take the root, right? Root. You will get, what was the answer? Minus 1.095. Okay. Now, what is the sample standard deviation of measures of site? For sample standard deviation, what do you do? You'll just divide
Sir,
by.
but the portion says that we have to write it down to the 3 decimal places, but the answer is 1.2, that is 1 decimal places.
1.2. Okay, what was it? 6 by 5 root, right? So let me calculate it. So 6 divided by 5 is 1.2. And did you calculate it? Did you took the root under root? No, right? It comes out to be
After
1 point.
1 point.
Yeah, you forgot the root, I think. Okay. Without the root, it is variance. Without the root, it is
Without the root, what it is? Standard deviation.
variance. Variance. How do you get standard deviation? Standard deviation is under root of variance, right? This term that is inside the root, right? Summation of xi minus x bar square divided by n. This is variance. Okay. I think you all have not watched the lectures. Okay.
Sir, I did the same thing, but my answer was coming 1.897.
Okay, where did you go wrong? I calculated it in front of you, right?
Yes, sir, same thing I did, but why my answer is different, I cannot understand.
Then check your calculator maybe.
Yeah. Okay. You got the sum 6, right?
For population, it's 1.2, I think.
For population, not 1.2, you'll have to take the root under root of 1.2, right?
Yeah, variance is
1.2.
1.2.
Yeah, variance is 1.2. For
1.2,
standard deviation,
2 is the answer.
no, guys. 1.2 is just this quantity that is inside the root. You have to take the root also. So 1.2, you'll have to take the root, and
Sir,
you'll
I'm
get
asking second question.
for second
Jo-
question. For second question, the difference will be here, right? You'll divide it by 4, right? You'll divide it by 4. So 6 by 4 root for sample standard deviation. So 6 by 4, that is, let me put the calculator. 6 divided by 4, it is 1.5, and then you'll take under root. You'll get 1.22, right? Whoever was it, it was right, right? 1.22. So, okay, yeah, this is another formula. Once you have this uh, population standard deviation, you can calculate the sample standard deviation using this, right? So what is population standard deviation? Population standard deviation is uh, just sigma, right? Sigma can be calculated as under root summation of xi minus x bar whole square divided by capital N, right? Or if the number of observations are n, let's suppose number of observations is n. So what you'll do, you'll divide by n, right? For population. For standard, for sample standard deviation, what will you do? Anyone?
Sir,
Do you
n
divide by
minus 1.
N minus
you
1,
divide
yeah.
by
Minus 1.
n minus 1. Okay, so from this above equation, what can you do? You can square this, right? Square this, you'll get sigma square, and sigma square is actually variance. Okay, this comes out to be xi minus x bar whole square divided by n, right? Now what you do is you bring this n to this side. Okay, you'll get the value for this quantity. This quantity will come out to be sigma square n, right? Now put the sigma square n here because we have the same quantity. So S, that is the sample standard deviation under root. Instead of this, you can write population standard deviation square, that is the variance, population variance, into n divided by n minus 1, right? So this is a square. So this will come out, and n upon n minus 1 will remain under root. And the sigma. Okay, got it, guys?
Yes, sir, got it.
Okay, so if you know the population standard deviation, you can calculate the sample standard deviation. Okay. So you can do it either ways. You can simply, what we did, right? We simply replace this 5 with 4. You can do like this also. Or if you want, you can derive this formula and use this also. Okay. What is the sample standard deviation of area of wooden sheet? So we calculated for measure of sides. The same will go on for the area of wooden sheet also. So here you can see there's the area of wooden sheet. You take the calculate the mean first and you calculate the difference. Now from this difference you calculate the square difference, right? You add up all this square difference 298.8 and you divide it by n minus 1, right? It's sample standard deviation. Okay. If anyone needs an explanation for this again,
No, sir.
okay. Now next is covariance and correlation. Okay. So covariance, what does covariance do? Covariance quantifies the strength of the linear association between two numerical variables. Okay. What does linear here means? Linear only means graphically. That is, if one variable is increasing, the other variable, whether it is increasing, whether it is decreasing, or it is constant, right? It has no relation with the first variable. So this is covariance, and correlation is a unitless measure of linear association between the two numerical variables. Okay, so let's go ahead with the question. Okay, this is the same data, and we have been asked to calculate the covariance between the measure of side and area of wooden sheet.
Sir, can you please last slide show?
Okay, so just like you calculate variance, right? Yes.
Below is a standard deviation for both.
Sorry,
Below is standard deviation for both.
this
Yes.
no, this is
Below
formula. Yeah.
below formula is standard deviation.
Yeah. This is standard deviation for both of that is the denominator, right? Denominator. This is the standard deviation for uh, the first variable, and this is the standard deviation for the second variable.
Okay, sir. Let's move to the question.
Yeah. So this is the data, and what is the sample covariance between the measure of side and area of wooden sheet?
Give us 2 minutes, sir.
Hmm.
Yes, sir, it's a little bit in here. It will
Okay,
take
anyone
little.
got the answer?
Sir, I think answer is 9.
9. Okay, so I will go ahead now. Yeah. So what you do is you have the measure of side 8.4. Yeah. See, measure of side is 23523. What is the area of wooden sheet? 492549. What you need to do is you calculate the difference first, right? Just like we calculated in variance. Calculate, you get the mean first for the measure of side, right? What was the mean? The mean was 3, right? So from the mean, you get the difference, right? 2 minus 3, 3 minus 3, 5 minus 3, 2 minus 3, 3 minus 3, and you get the difference. Same thing you'll do for y also, right? You calculate the mean for y, and then you calculate the differences. Now, in variance, what we need to do is, uh, you square this, right? Variance is defined for only one variable. So what you used to do was you square this. But for covariance is defined for two variables. So we multiply these two variables. See, this is the third column. That is, we multiply these differences. And see, you're getting 6.20, 29.6, 6.20. So these are the values that you get. Then for covariance, you just sum up all these values, 42. And since it's sample covariance, you will divide it by 1, 2, 3, 4, 5. So it's sample, so divided by 4, right? So 42 divided by 4. Did you got it?
Yes, sir.
42. Below 1 is standard deviation for x's and y's.
No, this is we are talking about covariance. Covariance is just this. See this? You calculate the difference xi minus x bar. You calculate the difference yi minus y bar and you multiply them. Okay. And if it is sample, you divide by n minus 1. It is population, you divide by n. Okay. This is how covariance is calculated. So what is this? Sum up all the values, the product of these differences, and you sum it. So these are the products, and this is the sum, 42. Okay. So you
Every
get
time we
the what?
every time we do -1 and -1.
No, not every time. If it is sample covariance, right? If it is population covariance, you divide by n. Okay. Got it or not? It's similar, just like we did in variance, right? In variance, if we are calculating population variance, you divide it by n, right? And if you are calculating sample variance, you divide it by 1 upon n minus 1, right? So here also, if there is sample, you divide by n minus 1. If it is population, you divide by n. Okay. And guys, answer, okay, please. So it's 42 by 4. Now 42 by 4 is 10.5. Okay. So should I go ahead now, or anyone have any doubt?
Got it.
So, okay, once you get the covariance, now the second question would be, what can you say about the correlation between the measure of side and area of wooden sheet? How do you calculate the correlation? You have the covariance. Now what you need to do is you need to calculate the standard deviation of x, right? And you need to calculate the standard deviation of y. Okay. And you need to calculate both these quantities. How do you get the standard deviation? You square them up, you divide by n, and you take the root. Okay. You square these up, you divide by, sorry, n minus 1. Okay. N minus 1, and you take the root. Okay. You get the standard deviation for both of these, and you will divide it by covariance, right? Are you getting this? See,
Yes, sir.
they have not showed the calculation, but the standard deviation for x will come out to be 1.224. What?
Sample for the first one is 1.22 earlier calculated.
Okay, yeah, we calculated it before, right? It was 1.224, and for the second one, it was 8.64. Okay. So now, what is R? What is this 10.5? This is the covariance we calculated, right?
Yes, sir.
Divided by 1.224 multiplied by 8.64. It is standard deviation of x and standard deviation of y. You'll get a value 0.993. Okay. Covariance has no range, right? Covariance can take any values. But correlation coefficient, that is R, has a range, right? It has a range from -1 to
1.
+1. And what about the unit? If the two units were, let's suppose, uh, they were meter and seconds, right? Any time. So what will be the unit of covariance? If x is in uh, meters and y is in seconds, what will be the unit
Sir,
of covariance?
Meter
meter
second.
second.
Meter seconds. Okay. See, because here this will have a unit of meter, this will have a unit of second. They are both are and I mean they have the product is then okay. So meter second is the unit, and what is the unit of covariance then? Sorry, covariance is meter second. What is the unit of correlation?
Correlation has no unit.
It is unitless.
It is unitless, right? Because this covariance will have a unit of meter second. This 1.224 will, that is the sample standard deviation will have a unit of meter. This 8.643 will have a unit of second. So this meter second will cancel out, and R will be a unitless quantity. Okay. So here we have calculated R. R came out to be 0.993. And since R is greater than 0.75, we can say that there is a strong positive correlation between them. Okay.
Last option was given linear. What was that?
Okay. Absence of a linear relationship. Okay, what can you say about the correlation between the? So is it strong? Is it weak? Is it moderate? Or there is an absence of linear relationship? So uh, does these two variables have a linear relationship? Can anyone answer this?
No, sir. These
Y
variables
equals to
have
x square.
quadratic relationship.
Yep, exactly. Okay, they have a quadratic relationship, right? 2 is being squared, 3 is being squared, 5 is being squared, right? So these two variables have a quadratic relationship, not a linear relationship. So that is the absence of linear relationship. Okay.
Moderate comes in between range.
But still,
Uh,
sir, linear relationship is also very strong because
yeah,
correlation coefficient is 9 point something, or 0.9 something.
yeah, exactly.
This is having a
So
linear
the graph
relation.
graph is somewhat like this, right?
Yes, sir.
So the linear relationship will look like this something. Okay. So that is also very strong. Right? Points are lying on this graph. Okay. If you draw a straight line through these points, they will have a, the correlation will be very positive, right? Will be strong. So yeah, but yeah, the option said that they have a linear relationship. That is not true, right?
Sir,
Yeah,
moderate is what range?
a moderate, it was from 0.5 to 0.75. Or am I wrong? From 0.75 to 1, it is strong, right? Let me write it. So this is your line 0. This is 1. From 0 to 0.25, there is no relation. From 0.25 to 0.5, there is low association from 0.5 to 0.75, that is moderate or medium association. Okay, got it? Okay. Now, next is point biserial correlation coefficient. It is used to measure the strength of association between a numerical variable and a categorical variable with two categories. Okay, so yeah, calculate the point biserial.
Please go back to the
Okay,
slide
you
one.
know the formula.
What is P0 and P1?
It's the proportion of zeroth category and proportion of category.
Sir, we can say P0 and P1 are relative frequencies of those two categorical variables.
Yep. Yep. Proportion, that is relative frequency.
Relative frequency of X and Y.
Yeah, for like X and Y. Okay, once we move to the question, I'll tell you what is P0 and P1. Okay.
And only there is a standard deviation of X.
Standard, yeah. Okay, what is when is point biserial correlation coming into picture? When one of the variable is numerical and one of the variable is categorical. Okay,
One variable is
categorical. So for the numerical variable only you can calculate standard deviation. Okay, you can't calculate standard deviation for standard deviation for categorical. Okay, so X is what variable is X? X is the variable, that numerical variable, and for the numerical variable itself you will calculate standard deviation. Okay.
Please help us in understanding this wala concept.
Okay, this point biserial. Okay, I'll
Yes.
give time for the ones who already know it, and then I'll discuss it in the solutions. Okay. Is the measure of side weakly influenced by factor? So there are two factories, say A and B, which produces a square-shaped wooden sheets. Okay, so this is the same data that we got. So we have the measure of sides, and we have a. Okay, this is not a question for point biserial. Let me see. Okay, factory A and factory B. Okay, factory is a categorical data. Categorical variable. Okay, are you getting this? Factory is a categorical variable now,
Yes, sir.
and these two are the numerical variables.
Yes, sir.
Okay, so there are two factories A and B which produces the square-shaped wooden sheets of varying length of sides. So is the measure of side weakly influenced by factory? So what is this question? What is it asking? Is the measure of side weakly influenced by factory? That is there some association between them? Okay. So what you need to do is, since one of the data is categorical and one of measure of side is numerical, you will have to calculate point biserial coefficient. Okay. Calculate point biserial coefficient for it.
Sir, you are not audible.
I'm not speaking anything right now.
Sir, I
Are
think
you
we
all,
should not, yeah, not doing anything.
okay, no one is solving this. Anyone?
Sir, I am solving it.
Only one? Let's solve it together. Hmm. Okay. So let 0 represent the wooden sheet produced by. So what we do here is, first thing is we encode. What do you mean by encode? There are two categories, right? A and B. So one category you give 0 and for other category you give 1, right? So here what we have done is 0 represent the wooden sheet produced by factory A. So what you'll do is you'll assign 0 to all the A's, okay? And 1 to all the B's. Are you getting this? Hello?
Yes, sir.
Yes,
Okay.
sir.
Yeah. So you assign 0 to all the A's and 1 to all the B's. Now, how do you calculate the proportion of 0? P0 is the proportion of 0 or the relative. You can say it as the relative frequency or the proportion. Okay. So the number of zeros, that is 1, 2, 3, right? Upon the total number of observations, that is 5. This is the proportion of 0. Okay. What is the proportion of 1? That will be 2 by 5. Okay.
Sir, my answer is 0.333.
Okay. Someone has answered 0.333. Yeah, write it. Okay. Okay. So you've got P0 and P1. Understood what is P0 and P1?
Yes, sir.
Okay. So P0 is now 0.6, P1 is 0.4. Now what you do is, for the zero category, what is zero category? Zero category is all the variables that have A. Okay. Not this. These three, you calculate the mean. So what is the mean of 2, 3, and 3? 3 plus 3, 6, plus 2, 8. 8 divided by 3 is 2.66. Okay. So you get the mean for 0. Then you calculate the mean for 1. One category. The category that we assigned 1, that is 5 and 2, B1, right? This one. So what's the mean of 5 and 2? 5 plus 2 is 7 divided by 2, that is 3.5. Okay. So you get the mean for the first category. So you have calculated four things. You calculated the proportion of 0, you calculated the proportion of 1, then you calculated the mean for y, that is for the category we allotted 0, and mean for category we allotted 1. Okay. The next thing or the last thing is, what is the numerical variable here? Numerical variable is this, right? The measure of sides. You calculate the standard deviation for this. You can't calculate the standard deviation for a categorical uh, variable. Okay. So measure of sides, you calculate the standard deviation. Okay. How do you get the standard deviation? You calculate the mean first for all the data. For all the data, the mean is out to be. Okay.
This
Who was
was
the
a
one?
frequency, I think we have done.
Yeah. So we actually calculated the standard deviation, right? You calculate the mean, you subtract the mean, you take the square, and then you add them up for all the numbers and you divide it by n. Okay. And you can get the what? Deviation, standard deviation. So let's see. Yeah. What is the standard deviation? That is 1.095. Okay.
N minus or n.
N. Okay. What does it say?
Sir, a
Let
standard
me check it.
deviation.
Yeah.
Obviously, we are confused with n and n minus 1. So
Mhm.
here, where we put this symbol, we always produce with n.
Yeah. You
Sir,
take
I took n minus 1.
what did it came it? Did it come 1.095? The person who
Yes.
took n minus 1, what was
My
the standard
query
deviation?
is, my query is population deviation and sample deviation. So population deviation, or is there any symbol else sample deviation?
For population, we use this, and for sample, we use simple S. Okay, are you getting this?
Yes, sir.
For
Got it.
population, we use this symbol, and for sample, we use simple S. So here we are using population standard deviation. Okay. So okay, you got all the values. Now, what is the formula for this point by serial? That is y0 minus y1 divided by the standard deviation into under root of p0 and p1. Okay. So what we do, we put the values and you get this. Okay.
Can you please put the value so that we can grasp easily?
Okay. So what is y0? Y0 was 2.67. Okay.
0.67.
What is y1? Y1 bar, sorry. Y1 bar is 3.5. What is the standard deviation you calculated? It was 1.095. Okay. 0.95. So this is one thing, and then under root P0. P0 was 0.6 and 0.4. Okay, 0.6 into 0.4. Okay. So 2.6 minus 3.5 is uh, 0. Okay, let me put it. Calculate 2.67 minus 3.5. It's minus 0.83 divided by 1.095. That is minus 0.75. So that is minus 0. What was it? It was minus 0.75. Then you multiply it by under root of 0.4.
20.
Okay, so you do this. You got this right? No, I'm skipping this.
Yes,
You'll
sir.
get the
Yes.
answer minus 0.37. So here the absolute value of point by serial correlation coefficient lies between 0.25 and 0.5, hence the measure of side. So since it is lying between 0.25 to 0.5, right? This is, I mean, we have a negative here, but if you check the absolute value, right? 0.37, it will lie between 0.25 to 0.5. That is, what was it? Where did I make that? Yeah. So it is lying between 0.25 to 0.5, right?
No.
So it is a low or a weak association. Okay. So hence measure of side of wooden sheet is weakly influenced by the factory. Okay. What is Sullivan?
Yes.
Yes, sir.
Okay. Now these are some easy questions that I just put in the end. A government agency aims to evaluate the cleanliness standards of hospitals in a specific district of UP. To do this, they randomly selected 20 hospitals and assigned each a cleanliness rating on a scale from 1 to 5, where 1 is very poor, 2 is poor, average, good, and excellent. Based on this scenario, which of the following statements are correct? Yeah, I'll not give time. Let's do it together. Okay, everyone. The sample
First,
consists of all hospitals in that district. Is it correct?
No, sir.
Okay, so what is the sample? In this
Sample is
scenario.
the 20 hospitals which are randomly selected.
Yeah, exactly. So the 20 hospitals that were randomly selected as a sample. So this is wrong, right? Then for the second one, the cleanliness ratings are measured on a nominal scale of measurement.
Wrong. It is ordinal.
Ordinal scale.
Ordinal scale. Okay, the third one.
It is correct.
It's correct.
Yes, sir.
Yeah, correct. Okay, the population is all the hospitals in the district. Why is it all the hospitals? Because the government agency wants to evaluate the cleanliness standards for all the hospitals in a specific district of Uttar Pradesh. Okay, so the population will be all the hospitals in that district. Then what is the fourth one?
Sir, this is also correct.
It is correct.
This is correct, right? Because we took a sample, and from the sample, we are giving some information about the population, right? That is called inferential statistics. Okay.
So what one word about inferential stats? What's that?
Okay. There is a population. Okay. You're saying this is a population, and you took a random sample from it. Okay. And using this sample, you calculate something and you predict something about the population, the whole population. Okay. This is inferential statistics. Getting it?
We are concluding something.
Yeah, we conclude something about the whole population, not just for this sample. We conclude it for the whole population. Okay. So, what was our population in this case? What was the government agency? What did they want? They wanted to assess or evaluate cleanliness standards of all hospitals in Uttar Pradesh, right? So, what is the population? The population will be all the hospitals in the Uttar Pradesh. Okay. Population will be all the hospitals in the district of Uttar Pradesh. Okay. But
Yes, sir.
they didn't ask all the hospitals. They selected only 20. Okay. So these 20 are the sample that we took from the population. Okay.
Yes, sir.
Okay. Now, in these 20, the agency concludes that the cleanliness standard is good. Okay. That is, uh, it is good. And they did it for the sample only. But now we concluded for the whole population. Okay. For all the hospitals, the cleanliness standard is good. This is inferential statistics. Okay.
Yes, sir.
Mm. So I think that was it. Then this is the last question. Okay, everyone just draw this, copy this table in your notebook right now.
Okay, sir.
Okay, because the questions are on the next slide. Let me see if I can.
Done.
Done.
So what is it? The environment researcher collected data on 20 regions and categorized them based on two variables. What is the type of the area? Type of the area can be rural, urban, suburban, or rural, right? Urban, suburban, or rural. And what is the air pollution level? Is it high pollution area? Is it moderate, or is it low pollution area? Okay. Now, based on this, what proportion of total regions have high pollution level? Okay. Yes.
Urban. Portion.
Mhm. What proportion of total regions have high pollution level? Okay. Mm,
9 by 20.
9 by 20. Okay.
Portion
0.45.
9 by 20 or 0.45.
6/8.
They have got different answers or same answers. I don't know.
0.45.
0.45. Okay.
0.45.
0.4.
0.45.
Everyone got 0.45. Huh? Okay. So the question is, what proportion of total regions have high pollution level? So high pollution level is 9, right? 9 out of 20 have high pollution level. Everyone got this, right?
Yes, sir.
Yep. That is 0.45. Now the next question is, what percentage of suburban regions have low pollution levels?
25%.
Got one answer.
25%.
25.
It's 25.
It's 25. Okay. So what percentage of suburban regions have low pollution levels? So first, what we have to do is we have to go to the suburban regions. How many of them? How many data came from the suburban region? 8, right? Then out of these 8, how many have low pollution? So low pollution is 2, right? That is 0.25 or 25%. Okay. So I think everyone was correct. Then are pollution levels and area type likely to be associated or independent? How will you answer this?
Yes, sir.
So, sir,
Associated.
different, not associated.
Not associated. Okay, one answer is not associated. Any more answers?
Sir, I think they are associated.
Do you think they're associated?
Associated.
Associated. Okay. So what we need to do is we'll calculate the row relative frequency first. So this will come out to be 0.6, 0.3, 0.1. Okay. This will come out to be 0.25. This will come out to be 0.5. Am I doing something wrong? This will come out to be 0.25. This is 0.5. This is 0. This is 0.5. Okay. Anyone who didn't got this? What?
These are associated.
Yeah. So what I did was I calculated the row relative frequency. Row relative frequency. How did I calculate it? I divided 6 by 10. So it was 0.6. Okay. I divided 3 by 10. It was 0.3. And 1 by 10, it was 0.1. Okay. Similarly, for 2, I divided it by 8. It was 1 by 4. 1 by 4 was 0.25. Okay. So this is how we calculate the row relative frequency. Now we compare the row relative frequency. This is 0.6, this is 0.25, this is 0.5. Are they different or are they similar?
Different.
Right. So if they are different, having an idea about high pollution or having an idea about type of area, you can predict something about the pollution, right? Because they are different.
Yes, sir.
And if you can do this, we can say that there is an association between them. Right? So yes, there is an association. Okay. Everyone got this or not?
Yes, sir.
Yeah.
Yes.
Between suburban and rural region, which has a higher percentage of low pollution.
Suburban region.
Suburban region. Okay, one answer.
Suburban region.
Suburban region. Okay. Suburban. So between suburban and rural region, which has a higher percentage of low pollution. So you go for suburban and you see that there is a 0.25 under suburban, there is a 0.25 percent 25% of them has low pollution. Oh, sorry, high pollution. 0.25 has low pollution and 0.5 has low pollution for rural. Okay, so which has a higher percentage of low pollution? That will be
Ruler.
rural. Yeah.
सर बट यहाँ पे लो पॉल्यूशन लिखे तो हायर तो वही जा रहा है ना रूरल.
So you will have to check low pollution first. Okay, so low pollution, and in that we have to check what is higher. So what is higher? Higher is rural, right? So answer is rural. Okay. Higher percentage of low pollution. Okay, so low pollution is are these two values. Okay, and which of them is higher? Higher is rural one, right?
Yes, sir. Yes, sir.
Yes, sir.
Sir, rural one is coming out to be high.
Right. So, yep, I think.
Sir, using the relative frequency, right? I use the relative frequency.
Yeah, relative frequency. Okay.
Okay, sir. Yes.
So, the question is between suburban and rural region, which are the higher percentage of low pollution? So, first you have to calculate it for suburban region. In suburban region, what is the percentage of low pollution? And in the rural region, what is the percentage of low pollution? Okay. So this you will get from relative frequency only. Okay.
Okay, sir.
Then, okay. So I think that was it. Thank you for attending the session.
Sir,
Thank you.
Yeah.
sir, sometimes it is very confusing to know whether
Yeah. I
question
get it. If it
whether
asks
the,
for divided by 20, or we should divide it by the whole relative frequency, right?
yes, sir. It is asking row relative or column relative. It is very confusing sometimes.
No. So that is not confusing. That will never be confusing. If you read the question 2-3 times, that will not be confusing. Okay. So,
Sir,
Yes, sir.
yeah.
That question, that confusing, the total one. Can you explain how can we understand that?
But okay, that might be confusing. But in your quiz one, they will be clearly mentioned, or there will be some hint. Okay. Or the question will be, I mean, it will be obvious whether you have to divide by total, or you'll have to divide by the row relative frequency or column related. Okay. But for row related and column related, it will never be confusing. Okay. So
Okay, sir.
but for what is row relative tells us? Okay, we are in urban. We have chosen. Okay, we are talking about urban. Now, amongst this urban, or in this urban, what is the percentage of high pollution? What is the percentage of moderate pollution? And what is the percentage of low pollution? Okay, how will you get this?
Sir, this is obvious. This is row relative.
This is row relative. And then, if you are talking about this, right? If you are talking like this, let me tell you. Okay, we are talking about high pollution area. Okay. Now, in this high pollution area, what is the percentage of urban? What is the percentage of suburban? And what is the percentage of rural?
Here we have to see the column.
Column, right? So row relative and column relative will never be confusing. Okay. For
No, sir.
total
Yes, sir. At
and
total
row
level.
relative, yeah, that you'll have to solve questions. You'll have to look all the wordings that are there. Okay, and you'll get an idea. Okay.
Okay, sir.
Solve the practice
Understood.
questions and that question. And if you ever have any doubt, you can post it on Discourse. We'll tell you the answers. Okay.
Okay, sir. Thank you, sir.
So I think this is done.
hello, sir.
Yes.
Sir, I have a doubt regarding exam, sir.
Exam. Okay, what doubt? I don't think I'll able to answer. Okay.
From where can I practice the previous year questions of qualifiers?
Yeah. Okay. Are you in any of the groups? I mean, can join some groups, right? The students make groups among themselves. And there are some websites if you search, but we don't have an official PYQ. I mean, we can't provide you official papers. Okay.
Okay, sir.
Yeah. So ask from your peers, or I mean, you can post it on Discourse also. Anyone will give you some website or some platform where you can practice. Okay.
Okay, sir.
Right now, even I don't, I mean, remember what was that. There are some platforms that provide PYQs. Okay. Then any other doubt? No. someone has answered quiz practice dot space something. Okay. So I think I'll end this meet now. Okay. Thank you guys for attending the session. Bye bye.
Thank you, sir.
Thank you, sir. Bye, sir.